Section 9.1, Inferences for Regression, Video 2. Before we move forward into actually estimating and inferring things about the population regression, we need to take a look at what the computer output is going to look like for our simple linear regressions. These computer outputs can be obtained by putting your two quantitative variables values into Excel and asking it to do the regression output. But in your homework and on your test, you will be given the computer output, so you won't have to know how to do it in Excel. I may make a short video to show you how to crank that out in case in the future you want to come up with your own regression for your own data sets. In fact, there may be some in the homework where they ask you to, so I'll look into that. But as far as the computer output for simple linear regression, I'm going to refer to an example on page 577. Specifically, this is example 9.1, where we're comparing the speed of a printer in pages per minute versus the price to see if the printing speed can be used to predict what the price of the printer will be. When you have a computer output, you're going to have a lot of values. Most of them will have 5 columns. One for coefficients, one for estimate, one for standard error, one for t-value, one for p-value. The rows will be set up based on the intercepts and the slopes. Now this one won't say slope, but here's how you know that this one is about the slope. The printing speed is going to be your explanatory variable. It's attempting to explain the price. And of course the price will be the response variable. It responds to the printing speed. So in the row that starts with the explanatory variable, that's the one where you can find your slopes. Now your slope and your intercept are actually going to be under the estimate column. So when you see your computer output in the intercept row under estimate, this is your B0. It's your intercept. And this is bothering me because I really thought that this was the coefficient column. I did copy it correctly off of page 577, but I'm just going to look at another example real quick to see if they just made a mistake in this one. And they did. How many years have I taught out of this book and I just now caught this mistake? All right. So I need to correct something that's in the book. This first column will not be labeled coefficients, because in the back of my mind I was thinking my coefficients are over here. It's the second column that should be labeled coefficients. So if you have your book in front of you, on page 577, go to that computer output at the bottom, cross out the word estimate, and put coefficient. What is this first column supposed to be titled? Predictors. The things that represent the variables in the equation. Now, of course, the intercept doesn't have a variable after it, excuse me, but it still needs to be listed under our predictors because it does help predict the response value. So, with the corrected column titles, your predictors, aka variables, aka pieces of your equation, will be listed here. In the coefficients column are the numbers that are in front of those predictors. Now, the intercept has no variable, so this is not in front of anything, it's just your intercept. But the coefficient of the explanatory variable is here. This is your slope. Now, we're given a lot of other values here, so let's just kind of talk about what these are. This standard error, let me put an asterisk by it, and I'll go down here and define what that is. The standard error here is the standard error used in estimating and testing beta 1. You know that there are standard errors involved in both building a confidence interval and calculating a test statistic and a hypothesis test. In these problems, the standard error that you will use will be right here. Now there's also a couple of other things that we could use. Double asterisk here. with the t-value in the pages per minute row. The t-value in the row for the explanatory variable is the test statistic when testing beta 1 is equal to 0. Now there's a formula for it, and I'm going to show you that formula and we'll use it because sometimes I won't give you this information. But that's what this t-value represents, the test statistic when testing whether the population slope is equal to 0. And this p-value over here, 3 asterisks, is the p-value when testing beta 1 equals 0. So we don't need the technology if we have the output because we already have our p-value. And if we're doing hypothesis test, it's practically over. I know we're not there yet, but if I was testing whether beta 1 is equal to 0, and this is my p-value just handed to me, what can I say? Well, this p-value is less than 5%, and from this point forward, the significance level will always be 5%. This p-value is less than 5%, which means in the context of a hypothesis test, we would reject a null hypothesis. Well, beta 1 is equal to 0. Is that the null or the alternative? It's the null. We would reject it and accept its alternative, which is going to be that beta 1 is not equal to 0. What does that mean contextually? Well, you'll see in a moment, but it means that the response variable, the explanatory variable is an effective predictor of the response variable. In other words, that the printer speed is an effective predictor for the price of the printer. So again, when you see computer output for regression, it's loaded with values, not all of which we're going to use. These things up here in the intercept row, if we were testing or estimating the intercept, we would use those, but we are not going to test or estimate the intercept. These values down here we'll talk about later, particularly this r squared, which is going to be a backdoor way to figuring out the correlation. Not correlation. Forget I said that. All right, so intercept here, slope here, standard error for when you're estimating and testing the population slope, test statistic for when you're testing the slope is equal to 0, p-value for when you're testing if the slope is equal to 0.